Hello guys, today we're gonna apply the naive matching to solve this problem. So I think this problem is really make you feel a little bit confused because the problem description, not the problem difficulty. So in this problem, you have a sequence here. It's just a string, all right, and a word. We can say that this sequence is the text and the word is the pattern. So, but this problem mentioned that we want to find the maximum repeating of words that can be become a substring of the sequence. So, for example, we have AB here. So if we repeat the word AB 2 times, so we have AB, all right. So we have AB here, so we can go here equal to AB. But if we repeat 2 times, all right, 2 repeating time, so we have AB. So AB is still a sequence of still a substring of the sequence, right? Sorry, because the sequence is ABC, all right. So the maximum repeating is the number 2 here, all right. So we have number 2 because if we try to repeat AB the 3 times, if we cannot substring of the sequence, all right. So we have AB here because sequence is ABC, all right. So, but AB 1 time is too small, and AB 3 times is too much, so AB is enough. So this is the maximum value. So the example that can make you feel it more confusing is this one. And I will show you here. So this is the word and this is the sequence. So what do you think? What is the result? So the result, surprisingly, astonishingly, it will be the number 5. Why? Because you see that here, we have it here. You see that we have A here, but you see that the next one, AABA, so here. But the next one here, AAB, it cannot be word AA 3 times here, so triple A here. So they are not continuous to each other. But if you move this one, AA here, see that I will split it so you can see it more easily. So we have AB here, AB here, AB, A here, and AB, A here. So we have 1, 2, 3, 4, and 5. So the result is number 5. But we start with at this position. All right, so we have so how can we solve this problem? Even though the problem description is so complicated, but it's just it's so easy problem. We can have a straightforward solution to solve it. So to solve it, we need that t length here means the length of the sequence here. And we have a W length. W length it means the length of the word. All right. So we try to we have result here. It means for saving the result. So you know that the maximum length of the word should be smaller or equal the sequence. So the word cannot greater than a sequence because we want the word repeat k time, but still a substring of a sequence, so it cannot be longer than a sequence. All right. So we can figure out the max repeat. It means the maximum repeat time will be t length divided by the w length. Because if we repeat more than max repeat here, the word will be longer than the text, the sequence. So we don't want that happen. So this is our upper bound for the repeated time. All right. So we have for loop here because we want to find the maximum repeating time. So it means we will in the for loop we go from the repeat from the biggest one to the smaller, all right, from the maximum repeated time to 0, all right. So we have 0 here. We can you can move to 0 if you want, all right, but I just move to 1 for the later sentence, all right, the later comment, all right. So we have a pattern. So the pattern we try to repeat it k time num repeat, all right. So we have offset here, we have a short here, all right. It means the short function we're gonna implement it later, all right. So we have pattern, the pattern, and we have a sequence. So we try to short the sequence, all right. We try to short the pattern inside the sequence. So if with this repeated time the pattern still the substring of the sequence, so we can conclude that this num repeated time is the result we want to find, all right. So if offset not minus 1, so it means this is the result we want to find, so return num repeat, all right. So if the pattern is not the substring of sequence, we try to reduce the number repeated time, become smaller number. So if we try every possible num repeated time and we cannot find any result, so we conclude that we return 0 here, because the problem requires that if the word not substring of the sequence, so we return the number 0, all right. So that's it. So we need to implement the short function, all right. So the short function here, we can develop a short function, all right. We have a button, we have the test, all right. So that's it. So we have t length equal to length test, we have b length equal to length button, all right. That's it. So we have for loop here, for offset here in brain, we have a t length minus b length plus 1, all right, as we discussed in the intuition, all right. So because you want to keep in mind that plus 1 here, all right, don't forget it. So we have pointer equal to 0, y pointer smaller than b length, yeah, of course. So if that's all right, offset plus pointer, yeah, that's it. Different pointer, yeah. So if we rec on the y, we increase to plus 1, all right. So if pointer equal to b length, all right. So that's it. So we return the offset, or the y we return minus 1, all right. So try to test with the local test case. All right, that's it. So we try to submit to the LeetCode server. Let's see what happened. All right, that's it. We got the acceptance. All right, so we can change, instead of using our own short function, we can try to use in operator in Python. All right, using in operator inside Python. So if the pattern in the sequence, yeah, that's it, in the sequence, so we can return the num repeat here. So that's it. Try to escape it and submit. Yeah, we also still get, but keep in mind that in operator here for string in Python is not naive implementation here. Actually, they are very complicated. They are using KMP if my memory serves me right. So you KMP algorithm and another one. So it's faster than naive solution here. So that's it for this video. So hope to see you in the next video. So we're gonna discuss another interesting. All right, see you then.